Hi there, Dr. Basha here with you. Today we're going to go over Chapter 1, Introduction to Computers and Programming. This is CS302, Introduction to Computer Programming or to Programming Languages. So here are the topics for discussion today. What's a program or why we program? We're going to talk about computer systems. We're going to look at a specific program and see what it's made of. We're also going to talk about input, process, and output, the programming process, as well as procedural versus object-oriented. So here are some keywords for you. A computer is a programmable machine that's designed to follow instructions. So in order to make a program do something for us, we have to write instructions, and those instructions is what make a program. In this class, you're going to learn how to write instructions in a programming language. Today, we're going to look at C++, but you could use Python, you could use Visual Basic, you could use Java, and so on. There are a lot of computer programming languages out there. So what you're going to be learning to do today is how to write a simple program that is going to ask for your name, but that will be later on. Understand that we program because we need to make the computers do stuff for us. So in order for you to be able to communicate with the computer, you need to learn how to program it. We all understand that a computer is composed of some hardware and some software. In the hardware part, we have what we call the central processing unit, or the CPU. The CPU is the brain of the computer. You also have what we call the main memory, or RAM, the secondary memory storage, which are your zip drives, your external hard drive, your flash drive, and so on. You have your input and output devices, which we're going to go over in the upcoming slides. So when you think about the main hardware component categories, we have what we call the input devices. You have the output devices. In the middle is your CPU, or your central processing unit, which is the brain of the computer. And you have the main memory. You see that the CPU and the main memory work collaboratively because the instructions are stored in main memory and the CPU executes those instructions. So you see the secondary storage devices that are optional. What is a CPU? So a CPU contains two main components, the control unit and the arithmetic logical unit. The arithmetic unit is the element that retrieves and decodes instructions. So the job of the CU, or the control units, is to find those instructions and to convert them into an executable signal. And the arithmetic logical unit is the part that takes care of the mathematic, or perform the mathematic operations. The CPU works in a cycle. So the way the CPU works includes 3 steps: fetch, decode, and execute. So the CPU is constantly looking for the next instruction, or retrieving the next instruction from memory, and then it decodes it. Decoding means translating or interpreting an instruction and generating a signal. And then it executes it, which means basically it routes the signal to the appropriate component, such as a printer or a screen. When you think about your main memory, think about where you store the data. So it holds both instructions and the data. So memory is volatile. What that means is that when you turn off your computer, whatever was in memory is gone. So it's erased when the program terminates or the computer is turned off. It's also referred as RAM, which stands for Random Access Memory. Your main memory is organized as follows. So the information, or the smallest units of storage of data, is called a bit. A bit stands for binary digits. So that's the smallest piece of information. Information is stored in a computer in a form of 0 or 1. What that means is that when there is electricity, when the signal goes through, that's a 1 or on, and when it's off, that's a 0. So a bit basically is the smallest piece of information. We generally talk when we talk about data, we talk about bytes. And when you think about a byte, think about 8 consecutive bits. So what you see on the right side here is basically a byte, which is composed of 8 bits. Usually a word is about 4 consecutive bytes and has an address, and that's what we refer to as a word. So when you talk about secondary storage, so we're talking about non-volatile data. That's data that is retrieved when the program is not running or the computer is turned off. So if you want your data to be stored permanently, you have to put it in a secondary storage. Remember, we said that RAM is volatile. That makes it not save your data permanently. So when the computer is turned off, the data is stored. So you need non-volatile devices to store the data. So that could be, for example, a CD, a thumb drive, a zip drive, and so on. Of course, we don't use floppy drives, but that's just to show you that in the past we used floppy drives, yes. So we talked about computers as that. Basically, when you think about a computer, you think about the input, the processing, and the output. So when we talk about the input, we talk about how can we send data to a computer. Remember, we said that a computer is a machine that needs to be programmed. So in order for the computer to do things for us, we have to give it data to process. So many devices can input data, among them the keyboard, when you type in, the mouse, when you click, the microphone, the scanner, the digital camera, the CD, and so on. And the flash drive as well. So when the computer processes that data, it needs to send it to us back in a form of maybe a printout. So when you think about output devices, it could be a printer, it could be a speaker, it could also be a flash drive. So think about output devices as the device that's used to give the results of the program execution. So we all use programs. There are different kind of programs. You have what we call operating systems, such as Microsoft, such as the iOS, or such as the Unix. So those are specific programs that manage the computer hardware. In other words, they run the system for us. Those computers, those programs are basically meant to run our computer in terms of input output. It manages all those operations for us. But we have other software applications such as like word processing, PowerPoint, or games. Those are specific programs that are meant to do other things. So think about the software as two kinds of software. You have the operating system and you have the application. So there are various programming languages. So we talked about a program as being a set of instructions that tell the computer how to perform a task. There are various programming languages. So a programming language, when you think about it, is a set of commands that are used to write the program. So there are low-level languages and there are high-level languages. Thankfully, now we use high-level languages. The reason why is because they're close to the human language and it's very easy to understand and to use as well. In the past, we used low-level languages. Those low-level languages are basically written in binary code using zeros and ones. So imagine how hard it is to program using zeros and ones, because that's not close to the human language. It's more close to the machine language. How do you write a program in a high-level programming languages and generate an executable file that is going to be able to run the instruction? So you start up by creating a file, and that file is what we call a text editor. There are various text editors. You could use Eclipse, you could use Visual C++. So those are IDEs that are available for you to use, and they provide you an editor, a compiler, and all these steps that are needed, as you would see. If not, then you could just look up online for an editor. Notepad could be used as an editor as well. Anyway, so once you create that file, you type in the instruction, you need to run your computer that program. By running that program, you involve a couple of steps. But as you would see, I will show you a demo and how you create a C++ program. In a few minutes, it's a click of a button. It does the pre-processing, it does the compiling for you in one click. So the preprocessor, this is all happening behind the scene. So the preprocessor, what it does, it takes that source file, which is your program, the one you just wrote, it converts it into, it adds actually other things to it. It converts it into a different source file by adding what we call directives, which are just programs that are out there in C++ libraries, and it adds them so that the computer is able to use those instructions. then it runs the compiler. So what's a compiler? It's a program that allows you to convert that source program into machine language. Remember, we said that computers only understand computer signals, zeros and ones. So in order for a program to run in the computer, the source file must be converted into machine instructions, and that's the role of the compiler. It also will require using what we call a linker, and the linker's job is to basically link the hardware-specific libraries to the machine instructions. For example, if you need to print your file, so you're going to need to have the linker, excuse me, link the library or the commands that are necessary to produce that executable file. So the linker produces the executable file once all the library code are added to the machine, to the source that has been modified by the compiler. Finally, if there are any errors, you're going to have to fix those. It will be detected by your compiler. It will tell you that there are errors. You're going to have to go back and fix those errors and execute the program. So think about it as follows. So you have your source code, which is the one that you just wrote down. You have the preprocessor that modifies the source by adding directives. Then you have the modifier source that goes into the compiler. The compiler generates what we call an object, and that object goes into the linker, which links it to hardware-specific code, and then you have your executable file, and that's the file that runs on the computer. So when you think about a program, you're probably thinking, okay, so how do I write a program? What goes into the program? Just like any language, it has specific things that need to be included. So when you think about a programming language, there are keywords, the words that have specific meaning. You have some program-defined symbols. You have, those are your variables. You have your operators. How do you do adding, subtracting, how you do mathematical operations. You have some punctuation and some syntax, some rules that you have to follow. Here's an example of a C++ program. So this is a basic program that asks the user to enter a name, and the computer tells back, says back what the name is by saying hello there, and it adds the name. So I'm going to go over everything that's in here in a few minutes. So also known, so you have your keywords, right? So your keywords are basically the words that are specific to the language. They cannot be used for any other purpose. They are written in lowercase. And an example of those keywords are using namespace, std, and you have the int main. Those are keywords, or what we call reserved words. You have to write them exactly the way they are. So, and you have like things that you create as a programmer. If you want to read someone's name, then you will have to create a variable name. This is not part of the C++ language. And you have rules, obviously, that you have to follow, which we will go over as well. So there are names that you cannot use, which are the keywords, pretty much. And there are rules in terms of naming the variable. You cannot start it with a number. And that will, we'll go over those specific naming rules. And then an example of that will be string name. That's defined by you, the programmer, and you choose to call it name. You can name it anything you want, but the data type is string in this case because you're going to input your name. A name is a character, is a bunch of characters. So that's a data type. Variables have various data types. Could be integers, could be decimals, that's double or float, and it also could be just a char or a character. So, and it also can add operations. If you're adding two numbers, then you would have to put the plus sign. Notice that the star is for multiplication and the slash is for division. And you have a very important operator, which is the equal sign. And we're going to go over that when we do operations. So the example that I showed you before says cout what is your name? So that's where the user, and you see the semicolon at the end, which is mandatory. So in this case, the program is asking the user to enter a name by